Hello friends, today we'll solve the problem which says that number of submatrix that sum to target. So the problem statement here says that given a matrix and a target, return the number of non-empty submatrix that sum to target. The submatrix is x1, y1, x2, y2. The set of all cells xy. So basically you are given a matrix like this and you are given a target value and you need to find how many submatrix are there which sums to the target value. So let's solve this problem. So how do we approach the problem or any problem that we get to something like this? This is a tough problem or it is under the category of hard. So first thing that we need to check is we can create another example for this submatrix or a matrix like this. Suppose we have a matrix like this, we have all ones here and then we are given that the target sum is 4, so we need to find all the submatrix where the target sum, I say here that target is equals to 4. So how do we approach this problem? So if we see here this submatrix and all the horizontal individually, all these columns will sum to 4, even all these rows will sum to 4. So all these are submatrix. So we will have like 1 2 3 4 like this, 1 2 3 4 like this, and then again we will have a submatrix like these two and these two. So this submatrix will also form a sum of 4. So this will be a solution. Then another solution will be this one where we have these two and these two as one. Similarly, we have the last two and last two here. This will form a sum of 4. So this will be a submatrix. So similarly, we will have multiple submatrix here which will give the target value of 4. So how do we approach this problem? So what we need to do is we need to first decide whether we are going to traverse row wise or column wise, and as per that we can find the sum. So if you see, if we go row wise, then we can simply add all these value and we can do a addition. So finally we got a 4 which is equals to the target, so we can tell that this submatrix has a sum of 4, or this submatrix is one submatrix which the sum of the value of this submatrix is equal to the target. Similarly for the other row also we can do same thing. We can do something like this, and then for the third row we can do something like this and for the fourth row we can do something like this. So from here clearly we can tell that all these four, wherever it says 4 4 4, it means these are one of the submatrix corresponding to one row. So we can say that the count is 4 here. Now if we look closely, so this was for each row. Now we can go down from each row, we can go down, we can start from this row and we can go down. So if I go down from here, when I reach here, the sum of all these 4 ones is equals to 4. So we have another submatrix whose sum is equal to 4, which is nothing but this matrix, the first column of this big matrix. Next thing that we can do is we can go down for this particular column. So if you go down on this particular column, 2 plus 2 4, so it means that the submatrix which reaches here, it means that the submatrix of size 1 comma 1 also has sum 4. So if I go from this 2 to this 2 down, so again I get a value of 2 plus 2 4. It means that there is a submatrix which is this submatrix and this down, this smaller one. So this is also submatrix whose sum is equal to 4. Now if I start from here and if I go down, then again I have a sum of 4, which tells me that even this submatrix, this 2 and these 2, so this submatrix also forms a sum of 4. So that is also one submatrix. Now if I go down from these 3, I cannot find anything. So it means that this submatrix of size 3 comma 1, 3 comma 2, 3 comma 3, all these does not give me a target sum of 4. If I go down from here, from 4 and down, so again these will be more than 4. So I can tell that all these submatrix means 4 comma 1 will give me one value, but 4 comma 2, 4 comma 3, 4 comma 4, all these submatrix will not give me a matrix which will have sum equal to target 4. Next thing is we need to consider all these matrix starting from this position and when we go towards right. So this submatrix and down one. So it will be these two and these two ones. This is also a submatrix. So how do I find the sum of these two submatrix? For that, what I can do is I can subtract the column sum. So if this one is C1, this other one is C2, next is C3, and then C4. So if I have to get the sum of this submatrix, so I need to go down from C3 here, but or if I have to get the sum of this submatrix, so basically this column C2 also is will give me one submatrix with sum 4. So for that, what I can do is I can just subtract this value from the previous column. So I can say something like this will all be 1, then this will be 2 minus 1, then 3 and 4, then again 2 minus 1, 3 and 4, and then again this will be 1, then again 2 minus 1, 3 comma 4, then again this will be 1, 2 minus 1, 3 comma 4, and this will again be 1, 2 minus 1, 3 and 4. So if I go down in this column, so it will be this sum will be equal to 4. This will give me another submatrix. And similarly I can go down to this, but we can create a submatrix something like this. It will be 3 minus 2, 4, 1, 2, 3 minus 4, 3 minus 2 and 4, 1, 2, 3 minus 2, 4, and this will again be 1, 2, 3 minus 2, 4, and this will be 1, 2, 3 minus 2, 4, and I can have another set which will be 1, 2, 3, 4 minus 3, again 1, 2, 3, 4 minus 3, then again I will have 1, 2, 3, 4 minus 3, and the last one also 1, 2, 3, 4 minus 3. So if I see all this combination, so again this will give me one row, one column whose sum is equals to 4. This will give me one column whose sum is equals to 4. This will give me one column whose sum is equals to 4. This will give me one column whose sum equals to 4. So this is how we will get the sum of all the columns, or will derive the column value or the submatrix which is not positioned at 0. So suppose I have to get the sum now. The next thing is, suppose I have to get this submatrix. So I start from this 1, I go here, and this 2 row. So this is also equals to 4. This target submatrix is equals to 4. So how do I derive this value? So this value will be equal to, so I go here, when I come here, so this value will be equal to, I will basically subtract this 4 from this 2. So I need to consider only this part of the matrix. So I need to exclude the sum that was there till this 2. So what I need here is I need 1, 2, 3 and then 4 minus 2 here, so that I can consider anything from this C3 to C4. I hope this is clear. This part is little tricky, and this is what we need to understand. So if I do something like this, 1, 2, 3, 4 minus 2, and again 1, 2, 3 and 4 minus 2. So if I go down this matrix, so this and this will give me this 4 minus 2, and this 4 minus 2 will give me a sum of 4, which means that there is a submatrix which starts at this point and ends at this point. So basically this submatrix, this and this will give me a sum of 4. Similarly, if I go down from here to here, again I will get 4 minus 2 plus 4 minus 2, which will be sum of 4, which means the submatrix is this one and 2, and then this one and 2. So this is the approach that we are going to take to solve this particular problem, and I hope it will be clear. If you have some doubt, then put it in the comment section. I will try to answer those, or you can go back, you can rewind the video and have a look. So let us try to solve this particular problem. Like I said, that first we need to get a sum like this. So we'll just put a corner case here that if matrix dot length equal to 0, then we return 0 here. Then we'll have int column equal to matrix dot length, and we'll have, actually the column will be matrix of 0 comma length, so this will be rows. We can keep it as rows, and we will have columns equal to matrix of 0 dot length, and we will have one count value. So this count will be equal to 0. This is what we are going to return in the end. So we'll return the count, which will give us the count of the matrix that we have. Okay, so till now it's pretty straightforward, and once we have these, we will just loop through our rows and and the columns. So int I equal to 0, I less than rows I plus plus, and we have for int j equal to 0, j less than columns and j plus plus. So the first value will be same, so I can start j from 1, column 1, because we need here the sum of we need to modify this matrix so that each row contains the sum of that particular row till that particular point, like this 1 2 3 4. So here we will have matrix of I comma j, matrix of I comma j is equals to that cell value plus the previous cell value, means the previous column cell value. So it will be matrix of I and j minus 1. So this will form a matrix something like this. So it will give me a matrix like 1 2 3 4 1 2 3 4 and 1 2 3 4. So once we have this, then what we need to do is we need to start from the first column and the first row and find all the sum matrix whose sum is equal. So we'll apply this logic. So to reduce the number of calls, what we need to do is we will take a map, and we'll have a map of basically integer. So it will be integer equals to new hash map, and in this particular map we'll store the transient sum, whatever sum we will get. Like here we did this 2 minus 1, or we have to take the sum of each rows. Right now when we start from first row, we go down and we need to take the sum of these rows. So these rows we will store it in a map so that we can pick up the value and how many times we get a sum which is equals to the target. So that is why we are going to use a map. So we can start from the first column. We'll say int start column is equals to 0 and start column is less than the columns and start call plus plus. This is the first call, and then we will have a current column. So first the start column will tell us which is the starting point, and the current column will tell us that at which column we are currently, so that for that particular column we can go down, because we need, if this is the start column and this is the current column, so we need to consider all these matrix. We need to consider these 2, then these 4, these 6 and these 8. So that is why we require 2 loops here, one for the current column and one for the start column. So we will have a cur column, and the cur column will always be equal to whatever the start column is there, will start from there. So that we can, if the start column is this, it means that we have already calculated all the submatrix starting from C0 or C1 here. We need to start from C2 now. If start column is at C3, so we need to start from C3 and go till C4. It means we have already calculated everything before C3. So this will be starting from the start column, and your cur column will be less than the number of columns that you have, and it will be cur column plus plus. Now every time we traverse the column, we need to reset the map value. So whatever map value that we have, we need to clear it, and we need to start the sum again. Why we need that? So that is because, so suppose I start from this particular column, I need to consider all the submatrix that start from the first column. So I need to take everything. Let me take another example here. So if we have this matrix where we have 0 1 0 and again 1 1 1 and 0 1 0. So when we start from the first matrix, or the start column is this one, so I need to consider all these matrix. So this one, this one, this one, then these three, this one, this one, this one, and then this particular matrix. When I'm done with that, then I need to consider all the matrix that starts from here. It will be these two, and then these two. Basically it will be 1 0. Let me go down. So when I start from this one, so all the submatrix that I need to consider will be 1 0, then 1 1, this 1 1, and this one, so it will be 0. So all the submatrix that I need to consider is these, and all these. Okay, so every time I need to take the sum again. So I will clear the map here. I will initialize the sum value to 0, and in the map initially I don't have anything, so I will put the sum value of 0 is equals to 1. So currently this sum is 0, so I have one entry for sum equals to 0. Now what I need to do is I need to go down for each rows. So I will say uh, int rows, or I think rows I have already taken. Yes, that I have already taken, so I can just say int row. So this will start from 0, which is the first row that is present here, and this row will be less than the rows, and it will be row plus plus. So once I go down here in all these matrix, so I need to check the sum. So sum will be equal to whatever sum that is already present there, plus it will be matrix of your row and your current column. So whatever your current column is there, that one, and we need to subtract from this value. Like here I did 2 comma 1, so this is when our current column or the start column, basically we have moved from here to here. So we have moved the start column from C1 to C2, so I need to reduce this sum by the value of this minus whatever the value of the previous cell was. So here what we will do is, so we'll reduce that sum, saying that if our start column is greater than 0, so in that particular case I will subtract the matrix value of the row and the previous column, or basically the start column, whatever start column was there, minus 1. So if I am starting from here, so I will subtract the value of this, otherwise we'll subtract 0. If the start column is equals to 0, so I don't need to subtract anything, so it will be value of 0. So that is how I will get the current sum. I'll get this sum, 2 minus 1 or 3 minus 2 or 4 minus 3. So once I have this particular sum, I need to check in my map whether the target minus this sum value is present or not. If that value is present, then I will increment my count. So I can say that I will increment my count by get or default, and this default will be whatever sum minus the target value comma 0. So whatever the sum minus target value is there, if that is present in my map, then I will use that. Otherwise I will put in my map, I will put the sum value that I have till now, and I will do get or default the sum comma 0, and I will do plus 1. So this is how I will increment the sum value. So if I start from here again for this particular example, if I start from this value, from the value 2, and I go down, so initially I have the value as 2. The sum value is 2. So if I go down here, I will find the sum value as 4. So 4 minus the sum is 4 and the target is 0. So 4 minus the target is 4. So sum minus target, 4 minus 4 is 0. So in my map I already have a value for 0, which is 1. So I will increment the count by 1, which means that I have considered this submatrix, the submatrix that starts from basically this submatrix, this one that starts from here, this smaller one. So that is how this will give me the sum. So let us submit this. Okay. Start column. This is start call. So it is accepted. Let us submit this, and it is success. So this problem is little tricky, and I hope the explanation was sufficient. It is little tough to explain it over the video without a whiteboard, but I have tried my best here. If there is any confusion regarding the approach or the explanation, do let me know. Do put it in the comment section, and I will try to answer it. So I hope this was informative. That's it for this video. See you in the next one. Take care. Bye.